Hi, boys and girls. This is your Lesson 11 Read Aloud. We are going to be talking about your hearing and the parts of your ear. Hear ye, hear ye. Today we're going to poke around in your skull once more to learn about another one of your sensory organs. I'll give you a hint with another one of my special riddles. We are located near your eyes. There are two of us. My twin hangs out on the opposite side of your head. We both hate the sound of sirens. What are we? You got it, your ears. Your ears work together with your brain to help you hear. Think about all the different sounds you hear throughout your day. You hear alarm clocks, water running, doors opening, horns honking, bells ringing, people talking, and so much more. Your ears are very important in the classroom where you need to listen in order to learn. Your ears help you thicken your cerebral cortex. You are going to hear about all parts of the ear that work together as an interconnected system. Your ear is divided into three sections: the outer ear, middle ear, and inner ear. Just like your eyes, only part of your ears is visible. The other parts are hidden inside the protective bones of your skull. Mammals are the only animals with outer ears. The outer ear consists of flaps on either side of your head, the ear canal, and the eardrum. Your outer ear flaps are called pinna. They are made of skin and a tough elastic tissue called cartilage. That's pinna. So that's this part of your ear. The bottom of each ear flap, or pinna, is called the earlobe, right here. It is much softer than the top part because it does not contain any cartilage. Some earlobes are attached to the side of the head, whereas others dangle loose. Do you know which sort you have? Mine are attached. You see that? Mine are attached. Check out all of your family's earlobes to see who has attached and who has loose ones. Shaped something like a cup, your outer ear is a sound catcher. It collects sound waves from the air around you and funnels them through your ear canal to your eardrum. Your ear canal is like a tunnel, about half as long as one of your pinky fingers. The inside of the ear canal is lined with tiny hairs, and earwax is constantly being produced by glands beneath the soft skin. Earwax prevents infections by keeping dirt and other particles from building up in the ear canal. At the end of the ear canal, sound bounces off a thin, flexible flap of skin that stretches across the end of this tunnel. This membrane, or thin skin flap, is called an eardrum. That's right in here. Because sound vibrates off it in the same way that sound vibrates off the top of a drum when it is pounded with a drumstick. Your eardrum separates your outer ear from your middle ear. Your middle ear is a tiny air-filled space just behind your eardrum. As the eardrum vibrates or shakes, three itty-bitty bones inside the middle ear begin to move too. These three bones are named for their shapes: the hammer, anvil, and the stirrup. They are the smallest bones in your body. The stirrup is the smallest of the three, no bigger than a grain of rice. See how tiny that is in there? So tiny. These three tiny bones form a chain held in place by muscles that leads from the middle ear to the inner ear. Okay, it's time for an experiment. Close your mouth and form a puddle of spit inside your mouth. As you swallow your spit, listen closely. Did you hear anything? You should hear a little click. The middle ear is linked to the back of your throat by a narrow tube. I did not know that. Whenever you swallow, chew, or yawn, the tube opens to let air travel in and out of your middle ear. That keeps the air pressure constant on either side of your eardrum, preventing it from bursting. Have your ears ever felt clogged in an airplane or while riding in a car over a mountain? Suddenly you hear a loud pop and they are fine again. The tube connecting your throat to your middle ear opened up. Thank goodness. Your inner ear is located inside your skull. It is the most complicated and delicate part of the ear, consisting of a maze of tubes inside a liquid-filled, bony, hollow space. So look all in here. This is your inner ear. At the end of the maze is a snail-shaped, coiled, bony tube filled with fluid. This part of your ear, lined with tiny hairs, plays a very important part in hearing. It is called the cochlea, which means snail in Latin. Some people who cannot hear get cochlear implants, invented devices that function just like the cochlea functions. The second part of the inner ear is the auditory nerve, which can be likened to the optic nerve of the eyeball. So here's the auditory nerve. You can see it goes in the ear and it travels to the brain. So just exactly how do ears work? Your ears collect sound waves or vibrations. Sound waves are tiny, invisible movements in the air. Sounds are heard only when these waves bump up against the outer ear and get funneled into your ear canals. Different sounds have different wave patterns. Loud sounds, such as the sound of a jackhammer, have larger waves than softer sounds, such as the purring of a cat. The louder the sound, the larger the vibration inside the ear. For you to hear sounds, vibrations must travel from your outer ear, through your middle ear, to your inner ear, and onto your brain for processing. Let's follow a sound wave through an ear to see how it works. First, the outer ear, or sound catcher, collects sound waves and channels them into the ear canal. Once the sound waves are channeled into the ear, they hit the eardrum, causing it to vibrate. As the eardrum vibrates, so do the three bones in the middle ear. Next, hinged together by miniature joints, the hammer hits the anvil, and the anvil hits the stirrup. All these vibrations in the middle ear cause liquid in the inner ear to vibrate as well. All of this is happening in just milliseconds, boys and girls. That is miraculous, in my opinion. That's amazing. Wrapped inside the cochlea is a long, narrow ribbon with thousands of hearing cells, each loaded with tiny hairs. The vibrations in the middle ear create waves in the fluid of the inner ear that cause the tiny hairs of the cochlea to ripple as well. Next, the sensory hair cells bend and stretch, producing nerve impulses. These signals are carried on nerve fibers or threads along the auditory nerve to the hearing center of the brain. The brain is able to recognize the nerve impulses or signals as sound, even determining the direction from which the sound comes. The brain receives lots of different vibrations at the same time and is able to tell the signals apart, passing the information along to you and allowing you to hear. These signals hardly ever get mixed up in your amazing brain. Just like the process of the eyeball working with light, the process of hearing sounds is also quite wondrous and miraculous. For some people, hearing is difficult or even impossible when one or more parts of this system are not working properly. When people are not able to hear anything, or perhaps only a very few sounds, we say they are deaf. Boys and girls, at this point, I'm giving you the clue word, the surprise word, bonus word, whatever you want to call it, secret word, and the word is hearing. So when you're finished listening to this, you're going to go on to step 1A, I believe it is, or 2A, and you're going to answer the Schoology quiz question, what is the secret word? And it is hearing. Your inner ear is the seat of your hearing, but it has another important job to perform as well. Your balance is controlled by your inner ear. Nestled beside your cochlea are three curved tubes called the semicircle canals. These canals are filled with fluid and lined with tiny hairs, just like the cochlea. Whenever you move your head, turning around, lying down, or bending forward, fluid inside the semicircle canals causes the hair to bend. The bending of the canal's tiny hairs sends nerve signals to your brain, to let it know where and how you are moving. Your brain then sends messages to your muscles to keep you steady, maintaining your balance. Have you ever whirled around so fast that you became dizzy and lost your balance? That's because the fluid in the canals kept moving for a few seconds even after you stopped. It's almost time to stop for today, but first close your eyes and fold your hands in your lap. Let's sit very quietly and find out how many different sounds we can hear in the room. What sounds did you hear in your room?